Every strong PKI runs on more than good crypto. It runs on clear rules. In this module, we'll turn business risk, legal, and compliance requirements into concrete certificate policies and controls that engineers can implement and auditors can verify. A serious PKI rests on three tightly linked pillars: policy, practice, and governance. Policy is the rulebook. It defines what good looks like, which identities you trust, what algorithms and key sizes are allowed, how long certificates live, and what must trigger revocation. Practice is how those rules show up in the real world: CA configuration, templates, enrollment workflows, automation, and daily operations. Governance acts as the referee. It checks that practice actually follows policy, manages change, and enforces accountability over time. You can think of the certificate policy as the what and why, and the certification practice statement as the how. The CP states the trust assumptions, the assurance levels, and how certificates are meant to be used. It's written for management and auditors, stays technology neutral, and changes slowly. The CPS translates that intent into concrete operations: specific systems, controls, key generation, backups, access control, and facility security that PKI engineers must actually run. Cryptographic policy is essentially drawing a box around what is allowed in your environment. It starts by deciding which algorithms are acceptable. For example, we only allow RSA and ECDSA, no EDDSA yet, or the reverse. It then sets minimum key strengths, such as 3000 and 72-bit RSA or P384 curves, to resist attacks for the expected lifetime. Finally, it approves specific hash functions like SHA-256 or SHA-3884, and explicitly bans legacy options such as SHA-1 and MD5. Different classes of certificates need very different lifetimes. Your root CA is the ultimate trust anchor, so you issue it rarely and give it a very long lifespan, often decades, while keeping the private key extremely well protected. End entity certificates for devices and users leave much shorter, typically 1 to 3 years, and public TLS certificates are even shorter. You also plan renewals with overlap so services can move to new keys without any outage. For PKI, you need clear rules for both creating trust and breaking it. On the issuance side, define what level of identity proofing is required. That might be strong in-person checks for admin certificates and lighter HR-driven onboarding for regular users or devices. On the revocation side, specify trigger events like key compromise, role changes, or system decommissioning, and attach SLAs to them. Then ensure revocations are reliably published via CRLs, OCSP, and stapling so relying parties can react quickly. In PKI, nothing should start as a script or a template. It starts as policy. The rule that says, for example, this certificate must represent a high assurance identity. That rule only becomes useful when it's translated into practice. Concrete procedures like in-person identity proofing and requiring hardware-protected keys. The final step is translation into technical control. Smart cards or TPM-backed keys enforced automatically by CA templates. If you stop at policy, you don't have security. You have wishful thinking. Certificate policy only matters if it's enforced, and that happens in 3 main places. First, CA configuration sets the hard technical limits: which algorithms are allowed, maximum validity, and CRL or OCSP frequencies. Second, certificate profiles define what a cert is allowed to do through key usage and extended key usage. Third, enrollment controls decide who can request what, with which names and policy OIDs, and whether approval is automatic or manual. In a serious enterprise PKI, where keys live is just as important as which algorithms you choose. At the top, the offline root's keys should never touch a general-purpose server. They belong in strongly isolated hardware that's powered off most of the time. Issuing CAs rely on HSMs and dual control, so no single admin can operate them alone. At the edge, end entity keys sit in TPMs or secure enclaves, following strict CPS rules for generation, storage, backup, and destruction. Compliance is about more than doing the right thing. It's about being able to prove it later. Every important PKI action must generate a log event: certificate issuance, revocation, admin changes, and HSM key operations. Those events are streamed into tamper-evident storage, typically a SIM, where they're time-ordered, protected, and correlated with other security data. Auditors then rely on these logs to reconstruct what happened, validate controls, and detect anomalies or gaps in your PKI governance. In a healthy PKI, governance is just as important as crypto strength. Policy decisions should be made by a steering or policy authority, not by whoever runs the servers that day. Operations owns maintaining the CA infrastructure and is accountable for keeping it secure and available. InfoSec and compliance focus on independent verification. They're responsible for audits and for checking alignment with policy. When these lines blur, exceptions creep in, documentation drifts, and overall PKI trust quietly erodes. A mature PKI is a living ecosystem, not a one-time deployment. You continually watch emerging cryptographic risks, new attacks, algorithm deprecations, and updated guidance from groups like NIST or the CA Browser Forum. Those inputs drive updates to your CP and CPS through formal change management. Next, you modify technical controls, so templates, CAs, and configurations actually reflect the new policy. Finally, you audit and validate, using exceptions and risk assessments to stay aligned with real business needs. Governance isn't a one-time document. It's a continuous control loop around the entire certificate lifecycle. During design, you define assurance levels, algorithms, key sizes, and who's allowed to do what. At enrollment, policy drives identity proofing, naming, and OIDs. In operations, it dictates monitoring, renewal, and key protection standards. And at decommission, it ensures revocation is timely and keys are destroyed correctly. For every second a key exists, policy should define what good looks like. In a mature enterprise PKI, policy is your blueprint and the technical stack is the building. Treat your CP and CPS as core security architecture. For every should in policy, define a specific control, owner, and validation. Then use governance to keep that mapping accurate as risks, regulations, and infrastructure change.